The art of mastering algorithms through practical Python tutorials in today's data-driven world. Understanding algorithms is essential for solving complex problems efficiently. This guide explores how algorithm tutorials can help you build strong foundational knowledge and practical skills in Python. Whether you're preparing for technical interviews or developing real-world applications, these tutorials provide structured learning paths that adapt to your pace and expertise level. Fundamental concepts in algorithm design. Before diving into coding exercises, it's crucial to grasp core algorithmic principles. These include time complexity analysis using Big O notation, space efficiency considerations, and recursive function design patterns. Understanding algorithmic paradigms like divide and conquer and dynamic programming helps identify optimal approaches for different problem types. For example, binary search leverages divide and conquer, while Fibonacci sequence calculations benefit from memoization techniques. Time complexity measures execution speed based on input size, often expressed as O, N, O, log n, or O, 2 to the power of n. Space complexity evaluates memory requirements, distinguishing between in-place and auxiliary storage needs. Getting started with Python algorithm tutorials. New learners should begin with basic sorting and searching algorithms to understand fundamental implementation patterns. Bubble sort, selection sort, and linear search form excellent starting points for building algorithmic intuition. Python's simplicity makes it ideal for beginners, but advanced topics require deeper exploration of recursion limits, list comprehensions, and efficient data structure usage. Practice implementing merge sort and quicksort to reinforce recursive concepts. Mastery through structured learning paths. Effective algorithm tutorials follow a progression from simple to complex concepts. Begin with array manipulation before tackling graph traversal algorithms or matrix operations. This gradual approach prevents information overload. Interactive platforms like LeetCode and HackerRank offer curated problem sets aligned with common interview questions. Completing challenges at each difficulty level ensures steady progress and confidence building. Advanced techniques for optimization. Optimizing algorithms requires identifying bottlenecks through profiling tools. Python's cProfile module helps pinpoint inefficient code segments, enabling targeted improvements. For performance-critical applications, consider rewriting hotspots in C extensions or using NumPy arrays instead of native lists. However, always prioritize clarity over premature optimization according to Knuth's principle. Profiling tools. Analyze runtime behavior with built-in profilers or external libraries like line_profiler. Data structure selection. Choose appropriate structures, e.g., heaps versus balanced trees, based on access patterns. Real-world applications of algorithm skills. Algorithms power modern technologies ranging from recommendation systems to autonomous vehicles. Understanding their inner workings enables better decision-making when selecting solutions for engineering projects. Machine learning pipelines rely heavily on efficient feature extraction algorithms, while blockchain implementations depend on cryptographic hash functions and consensus mechanisms. Explore domain-specific applications to find meaningful use cases. Recommendation engines. Collaborative filtering algorithms match user preferences with item similarities. Pathfinding. Dijkstra's algorithm finds shortest routes in weighted graphs used by GPS navigation systems. Common pitfalls and how to avoid them. Bug-prone areas include off-by-one errors in loops, incorrect base cases in recursion, and improper handling of edge conditions. Writing test cases for various input sizes reduces unexpected failures. When debugging, isolate individual components rather than examining entire programs. Unit testing frameworks like PyTest simplify automated validation of algorithmic correctness across scenarios. Edge cases. Always verify behavior with empty inputs, single-element collections, and boundary values. Recursion limits. Implement iterative alternatives for deep recursion to avoid stack overflow exceptions. Evaluating tutorial quality and resources. Select tutorials that emphasize conceptual understanding alongside code examples. High-quality resources explain why certain approaches work rather than just providing working code snippets. Look for materials offering visualizations, interactive simulations, or step-by-step walkthroughs. These elements enhance comprehension compared to static text-based explanations alone. Visual aids, animation sequences showing bubble sort steps increase retention rates significantly. Practice problems. Hands-on coding exercises solidify theoretical knowledge through application. Building your own algorithm projects create personal projects to apply learned concepts creatively. Developing an image compression tool using Huffman encoding demonstrates both theory and implementation skills effectively. Open-source contributions provide opportunities to review professional-grade algorithms in real-world contexts. Study existing implementations to understand best practices and potential optimizations. Portfolio development. Showcase algorithmic projects on GitHub to demonstrate capabilities during job searches. Code reviews. Participate in peer reviews to gain fresh perspectives on implementation choices. Community engagement and continuous improvement. Join online forums and attend local meetups to stay updated on emerging trends. Engaging with experienced developers accelerates learning through shared insights and collaborative problem-solving. Regularly revisit previously studied topics to reinforce long-term retention. Tracking progress through weekly study goals maintains consistent growth momentum. Study groups, collaborative learning environments foster deeper discussions and collective troubleshooting. Coding challenges. Weekly contests sharpen problem-solving abilities under time constraints. Conclusion. This journey through algorithm tutorials reveals that mastery comes from combining theoretical knowledge with hands-on practice in Python. By following structured learning paths and applying concepts to real-world situations, you'll develop robust problem-solving skills. Continuously challenge yourself with new puzzles and participate actively in developer communities to maintain proficiency. Remember, every great programmer started with a single algorithm and kept practicing relentlessly.